what we just took on our quiz and what we did, what we practiced yesterday and what we learned the day before. Okay, so what we talked about was a vertex form of our equation, and when we have a vertex form, we can find the turning point rather simply, or rather easily. So how would you find the turning point from this vertex form given to us? Oscar. So we know that the vertex form of an equation or quadratic is y equals a x. Sorry about that. A x minus h squared plus k. And so we know that our turning point is hk. So we can look at the h and the k from our vertex form and find a turning point. But the thing we have to remember is that it's a negative h, so we always have to flip the sign for our h. So what's our turning point for this equation going to be then? Bradley? It's going to be -1, -4. And that's because we have the positive ones, so we need to remember to flip the sign, and then we keep the same sign for k, so it'll be a -4. And then how do we remember whether we have a maximum or a minimum? Tiffany?
Whether the number outside of x is positive or negative.
So we're going to look at our coefficient for a, which in this case is 6, and then we're going to see if it's a positive or a negative. So if it's positive, that means the graph is facing up, and that means our turning point is going to be at the bottom. If it's a negative, our graph is facing down, and our turning point is going to be at the top, so we can get a maximum. So is our turning point, or is our coefficient positive or negative for this one? Positive. So we have a positive 6, and so that means our graph is going to be facing up, and so our turning point is going to be a minimum because it's at the bottom. So we're going to have a min for our graph and for our turning point. And then how do we remember our axis of symmetry, or the equation for the axis of symmetry? So the equation for the axis of symmetry is always going to be x equals h. And so what's our h for this problem? -1. So our equation for our axis of symmetry is going to be x equals -1. And lastly, we have our y-intercept. Unfortunately, when we have a vertex form of an equation, we can't just find the y-intercept by looking at one of the numbers. For the y-intercept, we have to sort of solve for it. And so I'm actually going to write it down here, even though this is a different part of the problem. I'm going to write it below. And so the first thing we need to remember is whenever we solve for our y-intercept, we need to plug 0 in for x. So anytime we see x in the equation, we're going to plug 0 in. So we have y equals 6, then parentheses 0 plus 1, close our parentheses, and square it, -4. And so what will 0 plus 1 give us? Just 1, because 0 plus anything is just whatever that number is. And then 1 squared is just 1 times 1, which is still 1. And then what's 6 times 1? 6. So we have y equals 6 minus 4, and then this is just y equals 2. And so this is our y-intercept. But we have to remember, as an ordered pair, our y-intercept is always going to be written as 0, and then the value we solve for, so 0, 2. And if we were to have a standard form, or if our quadratic was written in standard form, how we typically see it, it would be 0c, whatever our value for c is in that equation. And now, what we're going to look at now is that we can actually, in a fairly simple manner, turn our vertex form of our equation into a standard form. And all we have to do is sort of just expand it out. And so we have y equals 6x plus 1 squared minus 4. And because this x plus 1 is squared, we can rewrite it as y equals x, or 6x plus 1 times x plus 1 minus 4. And so we can sort of decompress it and expand it out in the two forms, or the two x plus 1s being multiplied by each other. And now we can FOIL it to get our x squared and plus x plus our c. And so with FOILing, we need to do first, so I'm going to actually rewrite this first. So y equals 6, and then I'm going to put everything I get from this FOILing inside my bracket. So we get our first, so we have x times x, which is x squared, and then outer, so x times 1 plus x, and then inner, so 1 times x, it's another x, and then last is 1 times 1, which is 1. And so when we FOIL, we get x squared plus x plus 1, which we can collect our terms. Will be with x equals 6, front or bracket, and then we only have one x squared, so x squared, but we have two x's, so we'll have 2x, and then plus 1, oh, I'm sorry, I lost my x, so it's 2x plus 1 minus 4. And now, to get rid of this bracket and make it more look like our standard form should, all we need to do is distribute our 6 in. And so everything is going to be multiplied by a 6, because when we distribute, everything gets multiplied. We need to distribute to everyone. And so we have y equals 6 times x squared is going to be a 6x squared. And then what's 2 times 6 going to give us? 12. So we'll have a 12x. And then 6 times 1 is just 6. And then lastly, we still have our minus 4. And so we have just one more step to simplify, and that's collect our constants, our negative 6 minus 4. What would that be? It's going to be a 2. So we have x, or 6x squared plus 12x plus 2. And this is the standard form of our quadratic that we were given at the beginning that was in vertex form. So just a refresher of what we did, we just expanded it out, we FOILed, we distributed, and then we collected our terms, and we had our standard form. So it's kind of a process, but it's not too lengthy of a process, nothing too difficult. And if we remember, we can check by looking at our y-intercept and seeing that our y-intercept was 0, 2, and we also know that in standard form our y-intercept is 0, c, so we can look down at our c, which was also a 2. And another way to check whether your vertex form and your standard form are the same is you can graph them on your calculator. Just put both equations in and graph them at the same time. And if you only see one quadratic, that means they're graphed on top of each other, and so they'd be the same. And we can try to write this out if you want to see it as well. So we'd graph our turning point first, which is negative 1, negative 4. So we'd go left 1 and then down 4. And then we also have our y-intercept, which is the only other point we have at the moment, and we'd go up 2 on our y-axis. And so our quadratic should look something like this if we were to put it into our calculator. Kind of a steep little quadratic. And so we just learned that we can go from vertex form to standard form fairly easily, more or less. And that wasn't too hard. But what we're going to learn about today is now going from standard form to vertex form, so the other way. And because both vertex form and standard form have pros and cons to them, we want to be able to use both. And so we want to be able to go from standard form to vertex form if we were given a standard form equation, or vertex form to standard form if we were given a standard form equation. That way we know how to use both, and we can use the pros of both forms. And so we can rewrite a quadratic equation into vertex form if we use a method called complete the square. And hopefully this should sound familiar to you. That was one of the things we just learned on our last unit. Except we're sort of going to change completing the square a little bit to work with our quadratic and to work with our vertex form. But the steps should look fairly similar to what we did last unit. So we rewrite the equation in the form c plus y equals x squared plus bx. And to do this, we need to get all our terms with the variable x in them on one side of the equation, and then the c and the y on the other. So the c and the y on the other side of the equation. So our x's are on one side, and then anything that doesn't have an x or a c and our y, our constant or y variable, is going to be on the other. And then like we do on complete the square, we're going to divide all the terms by the coefficient of x to make sure it's 1. So if it's not 1, we don't have to worry about that step. And then we are going to complete the square by adding the b over 2 squared to both sides. And hopefully that should look familiar because you guys were great at completing the square, so I'm sure you'll be great at this too. And then we're going to factor our perfect square trinomial. And then rather than solving for x like we would in completing the square, for solving for our quadratic roots, we're going to solve for y. And so when we solve for y, we're going to end up with our vertex form of our equation rather than just x equals a root. So that's going to be a little bit different. But it's not too hard, and I think you guys will be fine because you were really good at completing the square. So let's try this out. So we have y equals x squared plus 6x minus 6. And so what is our first step when we want to complete the square? We need to, we're finding the vertex form when we complete the square, but our first step with completing the square is we need to get all our constants to one side and all our x's on the other, right? So we're going to add 6 to both sides to get 6 over on our left side. So now that we have all our constants on one side and all our x's on the other, what's our next step, Tiffany?
Take 6 over 2 on both sides.
Yeah, so typically we would divide by our coefficient for a, but because that coefficient is 1, we don't have to worry about that step. So we're going to add b over 2 squared to both sides. And so our b in this case is 6, so we'll add 6 over 2 squared to both sides. And so we have y equals, or y plus 6 plus, what is 6 over 2 going to give us? 3, and then what's 3 squared? 9. So we're going to add, I'm going to get rid of that extra parenthesis. We're going to add for 9 to both sides. So we have y plus 6 plus 9 equals x squared plus 6x plus 9. And so what is 6 plus 9? 15. So we have y plus 15. And this is going to equal our right side. But if we remember, this is our perfect square trinomial when we complete the square. This is the one that's going to factor into the two same factors. So how do we find the factors of our perfect square trinomial? We can either split the middle, like we learned when we factor, or we can take an x to both sides, and then remember the sign that is in front of the b, and drop the sign down. We'll have a plus, and a plus, because our factors have to be the same. And then if we take 6 over 2, what we had in our squared that we added to both sides, we take that value, that's going to be 3, so we have x plus 3 and x plus 3, and that's a quick, simple way whenever we have a perfect square trinomial to factor it. And if you can't remember that, just factor by splitting the middle like you usually do, and you'll get it, and it shouldn't be too hard. And so we have y plus 15 equals, and then our x plus 3 and our x plus 3, they're the same, so we can condense them together. And so we'll have x plus 3 squared, and now our last step is to solve for y. So what do we need to do to get y by itself? Subtract 15 from both sides, and we'll get y equals x plus 3 squared minus 15. And this is our vertex form of our quadratic that we had before. So if we scroll back up, we can write it in our little box up here. We'll say y equals x plus 3 squared minus 15. And now that we have our vertex form of our equation, we can find the turning point without having to do our negative x or our opposite of b over 2a formula. So what's the turning point of this equation going to be, or this quadratic? Oscar? Negative 3, negative 15. And that's because we need to take the opposite sign of our h, which was 3, and then we take our k, which is negative 15. And now we can use our standard form to find our y-intercept of our quadratic. And what's our y-intercept going to be? Hayden? 0, negative 6. Because our y-intercept of our quadratic was always 0, c, and our c for our standard form was negative 6. So our y-intercept is 0, negative 6. So we're going to do one more problem, and I think you guys, your eyes might be rolling in the back of your head because you're really good at this, and you guys know how to complete the square. But we're going to just do one more problem just to work on it, and then we'll have some practice. And so, once again, what's the very first step we need to do when we complete the square? Practice. We need to move our c to our other side. So we're going to add 20, which is our c, to the left side, or to both sides to get to the left side. So we have y equals, nope, old habits die hard. Typically when you write things, it's typically y equals, so it's y plus 20 equals x squared minus 8x. And now what is our next step that we want to do to complete the square and get this in our vertex form? Bradley. So we want to add our b over 2a to both sides, or b over 2a squared to both sides, which is, in this case, our b is negative 8. So we're going to add negative 8 over 2 squared to both sides. So now we have y plus 20 plus, what is negative 8 over 2? Negative 4, and then what's negative 4 squared? 16. So we have plus 16, and then whatever we added to one side is going to be the same on the other because we added our negative 8 over 2 squared to both sides. So we have x squared minus, that's not a minus, minus 8x plus 16. And now we can collect our terms on our left side. What will 20 plus 16 give us? 36. And now on our right side, we have the perfect square trinomial. And so this is our trinomial that we're going to factor. So what will the factor be? Tiffany? Not x minus 8. Oscar? X minus 4. So we need to remember that the number that we're going to have in our perfect square trinomial is going to be the same one that we added to both sides before squaring it. So it's 8 over, or negative 8 over 2, which negative 8 divided by 2 is negative 4. So we have x minus 4 and x minus 4. And so we have y plus 36 equals, and x minus 4 times x minus 4 are the same, so we can condense them to an x minus 4 squared. We can compress them together. And now our last step with completing the square to get a vertex form was to solve for y. So how are we going to get y by itself? Jordan? We can subtract our 36 or our c back to the other side. And now we have y equals x minus 4 squared minus 36. And this is our new vertex form of the same quadratic that was given to us in a standard form. And so we can see now what we can find from having both these forms. So we said our standard form is y equals x minus 4 squared minus 36. So what is the turning point of this quadratic? Of this vertex form? What was that, Madeline? Close. So we always have to remember to flip the sign for h, so it's going to be positive 4, negative 36. That's a common mistake that a lot of you will probably have trouble with. I even, when I'm writing down the vertex, I'll sometimes write the negative in there when it's supposed to be a positive. So it's something you just have to keep working with and you'll remember it. And so what is our intercept, or our y-intercept going to be? Tiffany? 0, negative 20. Because we can find our y-intercept from having the standard form, and that was always 0, c, and our c is negative 20.